You're listening to a Pop House Network podcast for developers by developers. Welcome to Java Pop House episode 99. Hey everyone. We are in the throes of winter, getting close to the end of the year. Today's episode is going to be around secrets, so it is going to be fun. My name is Freddie Game. For those who are tuning for the first time, I'm one of the co-hosts here at Java Pop House. I'm principal engineer at Expedia, author, speaker, Java champion, and I'm here with my partner in crime, Bob.
Everybody, Bob Paul, an independent consultant from Chicago, Apache Software Foundation member, Java champion, and CJUG board chair.
All right. And before we invite in, I wanted to thank our sponsor, Datadog. Today's show is sponsored by Datadog, a monitoring and analytics platform that integrates with over 450 technologies, including AWS services, Docker, and Kubernetes. Datadog's platform brings together metrics, traces, and logs in one place so you can get full visibility into your environment and improve your application performance. With machine learning-based alerts, customizable dashboards, and distributed tracing, Datadog makes it easy to unify disparate data sources so you can troubleshoot faster. Start your free Datadog trial today. Listeners of this podcast will receive a free t-shirt once you install the agent and create one dashboard. Visit javapophouse.com/Datadog to get started. Again, that URL is javapophouse.com/Datadog. And we thank them for keeping and supporting this podcast and essentially leaving the microphones on and the beers flowing. Thanks, Datadog.
Cheers.
Cheers. All right. So for today's topic, we wanted to talk about almost like an interesting topic that a lot of people sometimes think they got it right, and then we tend to get it wrong, especially if it is the first or second or even the third time you're doing this around. And it's about secrets or passwords or tokens and all these other things that we are supposed to keep to ourselves and not share anywhere else.
Right. I mean, if you're doing anything interesting in development, you're talking to a data source, you're talking to another API, you're talking to a vendor, which is protecting that API because they have something interesting behind that. They don't want it to be available to the entire world, right? I mean, first apps, school-based projects, everything is wide open. We're just talking to everybody, but that's just not how the world works, right? Data is king. Data is money for companies. And I mean, there's been so many things in the news recently about data getting stolen, data being, used against people for credit cards. And one of the biggest things that leads to data leakage is if you have one of those secrets that is supposed to protect that data get out. And, unlike social engineering where somebody is tricking you into giving them information, this is something that as a developer, we have some control over, right? So we are the ones writing the code that is working with these secrets. We are the ones in charge of deciding where we store them. We're the ones deciding how we store them. So it's an extremely important topic for developers, and it's one of those that again, the first time you approach it, you might think you got it down, and then you realize, oh shoot, it's out, and I'm in trouble here. So a couple of things to share that you've done. I mean, the very first time you get a password, the first time for me with dealing with secrets was database password, right? So, I mean, every app right? In the late 90s to the early 2000s was a web service talking to a database. And it's still probably a fairly common use case.
Yeah.
And what's the first thing you do? You have your JDBC driver, and you're dropping that password hard-coded into the source code and making sure that it works. And then you commit it and you're like, hey, I'm done, right? No.
How many
oops.
how many oops have been said on that? So, okay. So walking through that example, right? It tends to be like this JDBC string. Like sometimes the JDBC will allow you to use username and password on the string, and you either put it within the code itself, or maybe you just say like, oh, I'm going to put it on like a configuration file, right? Like, you know, like it used to be XML. Now people move to YAML, and you know, Spring is you know, has very specific places where you can put all these attributes, which is very, very nice. But the first rule of secrets is like you never put it in the code that you're working with. And the reason is you know, going to the bots example where you put it on the actual string, and then you commit that code like to GitHub or to your internal source repo. The problem that you have is that now that particular piece of code and that particular password or that particular secret is part of the history of the commits that you have done for that project. And somebody who is, you know, crafty enough can just say like, oh, let me just search on GitHub or my local GitHub or my local source control version.
You don't have to be too crafty, right?
It's a search box.
It's a search button, right? Like,
equals.
So
and then
this is stuff our parents can do. They're getting better, at least.
No, it was funny because like that was one of the things that people will do on github.com. They would just go and search for password equals and then see what came up. And then coders, like there's 11 million commits that says password equals, but I think GitHub got the got the win that, oh, people might be doing that. But that is the problem. It's like all these things when they go to source control and trying to remove it, it's a nightmare.
Yeah, you really can't. I mean, again, I'm not the only one and I won't be the last one to do this. And, you know, if you find yourself in that situation where you have accidentally or on purpose and stupidly committed a password to source control, your only mitigation option is changing the password. You have to invalidate it, change it, burn it. Yeah, that thing cannot be used again because somebody is going to write a script to guess exactly that for your code.
Right, and that is one of the like the things is that you know, sometimes it could be like a quick and somewhat painless, right? Like it's like, oh, I control the database, I control everything, I can just reset the password on the data source and we're good. If it happens to be an API key or an API, like a third-party provider password, then that's when it gets prickly because that now you have to talk to like, hey, you know, third-party provider, I need to change my password. Hopefully they'll have an UI interface where you can do that, but sometimes depending on the API, it's relationships and you have to talk to them personally and say like, oh, can you issue me a new password? But the point being, like, you do, like, if you do make this mistake, please, by the love of everything that's holy, go and do change it, because there is people that will just, like, you know, again, from anywhere from disgruntled employee that just got fired to some hacker trying to figure out that got access to some of like the source code, or somebody inadvertently left something open, they will be able to find it. So and please don't make it like password 123 and get to password 124. Like,
yeah, I mean, strong passwords is certainly an important thing, but I mean, it also brings up another point about password management and design. You know, one of the reasons folks may be like, oh no, we need to figure out a way to delete it, because if I change it, I've got to go across 6 or 7 other applications and change it in there too. And now we have to synchronize it. It also brings up a great design point when you're using a microservice and you're issuing credentials, having separate credentials for each application. This is why you do that. So if one of their keys escapes, gets compromised, you don't have to go in and make 6 or 7 different config changes. You just have to fix your one app that got compromised. So, I mean, it may seem like, well, they're all talking to the same data source. Create different credentials. It will save you time and coordination when bad things happen. And explore like interesting enough, right? Like on the database side, a lot of these
data sources, what they have is almost like trusted authentication now, like where you don't necessarily require username or password, but what they're saying is like, oh, you are accessing this from what we consider a trusted source, right? And that is sort of like, for example, SQL Server will have the SSPI, where it requires you to have like a computer that is logged into the Active Directory domain and has LDAP credentials. So the computer itself is like, I trust that computer already because it's on my LDAP cluster. I don't need passwords. You can access the database, right? And the cloud providers are offering that sort of kind of trusted source where, I think in AWS is IAM, Identity Access Management, where you can say, oh, this particular EC2 instance has this kind of permissions and it has access to these resources, including my DynamoDB table or they actually have a flavor of MySQL that you can spin up that will have IAM authorization, which is like the little like twist that they did, so you don't have to deal with MySQL passwords. And if you have the capability of using that for that resource, it's going to be confusing. I'll tell you this much. It's going to be confusing the very first time you read it. It's going to be like hairy until you figure out, oh, that's what they mean by LDAP and SSPI. But so worth it, because that means you really don't even need to know secrets. Like that is just the entry level best solution. But like we know, sometimes you can't do that, right? So
yeah, I mean, most organizations have kind of a separation between development and operations. I mean, there's always folks that have a little bit of a crossover role, DevOps, folks in development that have operational access. But like, the beauty of not having to deal with a secret is really your best case scenario. So having an IAM role that says, if I apply this role to this machine or this, if it's a function or whatever you're using, that role is what is granting it the access. I don't have to worry about storage. I just have to worry about who has access to apply that role to machines. It changes the nature of the game. Because once you're dealing with secrets, those can get out. When you're talking about roles and things like that, you're talking about access control, which is a lot smaller surface area than secrets management. So it changes the game entirely. So those are all really good things. So if I'm able to eliminate the secret, that obviously is the best route to take if possible.
But like, and I think like, Bob, you've been hinting at something, right? Where it's, so what we're saying is like, don't use secrets if you can avoid it. If you have to use secrets, we're saying like, oh, it's a very bad idea to put it on the code, very bad idea to put it on configuration. So a lot of people then are left wondering, okay, then where do I put this thing?
Yeah. I mean, so it's actually evolved over the years. Again, like when I started doing development work, it used to be, well, okay, you have a secret, but we're not going to put it in clear text. So what we're going to do is we're going to have a library that is going to decrypt the secret. And the password is going to be passed in some type of runtime variable, whether it's passed in through an environment variable or a system property. That's going to be the key that's going to access it. So we're still checking the secret in to source control, but it's encrypted. So it should be safe, right? I mean, that's the approach that a lot of applications took probably 10, 15 years ago, but even a lot of that have evolved out of even keeping the secrets out of the source code encrypted even, because what we're finding is as, algorithms and CPU power increases, cracking some of these algorithms have become simpler. So the fact that it's in source control at all means that somebody can have, even if it's encrypted, a significant amount of time to crack it.
Right.
So what's, the next evolution of that is, okay, if we're not going to put it in and check it into the source code, can we pass it in through, say, an environment variable or something like that, where maybe it's an encrypted environment variable and we're supplying the key. So both the key and the secret are not in the code. And that's better, right? So it's better because even if I have source access, I'm not looking at the secrets. I have to have whatever operational system has access to those environment variables.
Right.
And that's a little bit better, but you've also still got your exposures there as well. You know, if you're dealing with a Kubernetes and you have your YAML files checked in somewhere, I'm at least going to know the name of that environment variable. There's going to be things that I can get after that are available to me within my organization.
Right.
So, and I can do things like scripts on the box, like print env,
Right.
which
Right.
are going to like, hey, now I have all your secrets and I don't even need to know the names of them. So we've evolved to that. And now I think that probably the best practice now is a lot of the cloud providers, even some companies offer basically distributed secret management, either through a secrets manager app or a vault. So, I mean, most of what I'm seeing, you know, with a lot of my clients are implementations that are using secrets managers over API, and basically the applications are storing key values, whereas the key is just the name of the secret. And those applications are granted roles that allow them to read the secrets manager. So you don't have a secret to read the secrets manager. It's a role-based policy that allows me to get to the secrets manager and access API keys, passwords, things of that nature.
Right. And that is essentially what is now considered a common practice, right? So, and again, if you this is the first time you're starting to get into managing secrets, this hurts, right? Because like it's like, oh, I thought I could just like, I kid you not, some people thought base 64 encoding was a form of encryption. And just so if it crossed your mind, it ain't. Like it's an encode. It encodes and decodes for usually for being able to use this as an ASCII, like, you know, the 26 characters or whatever it is, 52 characters, but it is not encryption, by the way. So never use base 64 thinking that encrypts anything. It doesn't. But the idea is that, you know, what we're trying to make sure is that you're starting to get comfortable that, you know, that even though it sounds very complicated, a lot of this is really industry standard. Like, you know, especially once you start, and again, you might be on a particular part of a domain where is not essentially software first. And what I mean by that is there might be like you're part of an industry that is, or part of a company that is a lot of brick and mortar and maybe has a smaller IT department and they don't get exposed to these things. But we're here to tell you that, look, if you do have a secret or something that is important and you want to protect, you do need to onboard yourself into these kinds of technologies. Either, you know, if you're using a cloud provider, your cloud provider will have some kind of secret management. You know, we can go over, and I think we'll go over a little bit in a little bit of time, like, for example, how AWS does it. Or if you don't even have a cloud provider, there is like third-party solutions that, you know, your IT department can manage. Like, you know, I know, like, I think Vault is one of them.
Yeah, HashiCorp has Vault.
HashiCorp,
you know, so there's community editions of that. But yeah, I mean, a lot of them use a lot of the same mechanisms and how they work. So, I mean, as far as like when I'm writing my code and how I'm using them, it's going to be fairly similar once you move to these kind of outside of your app hosted secret management solutions, which could be a Vault, could be a secrets manager. But I mean, why are these superior to some of the other things that we have talked about or the other approaches we've talked about? So, I mean, within a secrets manager, you are storing a version of the secret with a key name, so you can identify the secret, and also the value. But rather than storing it, you know, like I did in my first example with clear text, pasted into the GitHub code, most of these, well, no, I shouldn't say most, all of these secrets managers are encrypting these values at rest. Meaning, you know, if I'm AWS and let's say I am able to hijack just the storage solution of Secrets Manager, I am still looking at your encrypted secret. I'm not getting the value, because what's happening is most of these cloud providers have a separate service that are providing encryption keys for these values. So in order for me to actually extract your secret value, I need both. I need what it was stored at, as well as the key that was used to encrypt it so that I can decrypt it and get your value. So, it allows the cloud provider to store your secret in a way that, as long as whoever that, attacker might be, if they don't have the key, it's not of very much value to them to be able to get into the storage.
And to add to that, it's like this particular solutions is something that you get very, very smart people really thinking like, what is the horizon of how they are encrypting? Are they using, like, are they using like, SHA 1024? Are they, is there a problem with that? Do we need to re-encrypt this? And it's one of the things that you learn is like security things are better left to people that are concentrating on just that particular domain, right? I remember infamously the very first Bitcoin exchange, the guy who did it, who ran Mt. Gox, he decided that, oh, I'm going to implement an SSL protocol, a secure sockets layer protocol over the weekend. And of course he did. And it had so many security holes that what happened was that Mt. Gox, which was the first Bitcoin exchange, essentially all the Bitcoins got funneled out because there was essentially not even an overflow error. It was just like, oh, this was poorly implemented. I can just go in. And they like Bitcoin lost like Mt. Gox lost all its Bitcoins in like overnight. That was kind of like crazy to see. So yes, the moral of the story, never try to be smart. Like, oh, like if it crosses your mind, no, I'm gonna re-encrypt it on my own, and I'm going to put, SHA 256. I'm gonna hash it, and I'm gonna put a salt and pepper or all these things. It's like there is a chance that you might get it right, but if history is any like a predictor, chances are you might get it wrong. Yeah. So yeah, leave it to the experts, leave it to Amazon, which pays somebody, 10 times our salaries just to look at that stuff. Plus the interesting part is they add these kind of features that will be extremely hard to implement, right? Like not just the encryption part, but I think that one of the things that always comes to my mind is like, what happens if I need to change the encryption, right? What happens if I, there is this concept of rotating things, and why don't you let you talk about that one, Bob?
Yeah, I mean, so key rotation is something that gets baked into a lot of these secrets management solutions. So, even if I don't change my password very often, I can, change the key that it's being encrypted at rest at. So, I mean, for example, one thing that could happen is knowing encryption is basically, it's very hard math at the end of the day, right? Yep. That takes a very, very long time to crack. And the longer you have to work at a value, the more likely you are to be able to figure it out. Right. So one thing I can do to try to keep people guessing, and I do need to change my password from time to time as well, but I can also change the keys that are used to encrypt it. So if somebody were to try to crack my key and expose all of my secrets, I can rotate that key independent of the secrets values. So I can generate a new key, re-encrypt everything that I have at rest, and then have a process of moving all my applications, which are still dependent on these keys, to use the new encryption key without changing a line of code. And that's really powerful, right? So, I mean, I have the ability to keep myself more secure without changing code. When you're talking about all of these approaches that we used to do with encrypting things, checking them into properties files, or even environment variables, like you are on the hook for all of those operational changes. Whereas, if you have a service that just does key rotation for you, your SDK is going to take care of calling, getting the new key, and then applying the new key, and your app just keeps humming along. So it's a nice situation to be in.
Right. And so let's go over a little bit just the mechanics on how it happens. Usually, when you want to encrypt a secret, right? And this is sort of like background information, why key rotation, like just highlighting a little bit more of like why key rotation is so cool, right? The way that it works is, let's say that I have a string that I want to, there's my password, and I'm going to pick a bad password. I'm just going to call it password, right? And then there is this essentially almost like this random string, which I am going to call my key. So when you have your password and you have your random string, you sort of feed it into this particular algorithm, and that's where you get SHA 256, SHA 1064, MC5. There's so many that will take and essentially almost like take these things and they start fending off with each other and doing their math. So what happens is at the very end, you get a new blurb of something that is unintelligible, right? Like it's just a bunch of bytes that are essentially, like that are completely unrelated to the two things that we're feeding in. Now, the way that this usually works then is that if you have enough time and you sort of try to guess oh, maybe somebody type in password, then I can try to figure out what kind of like feed in onto the same algorithm to try to get to that key. And this is sort of what Bob is trying to say, like, if there was enough time in the world, I'm guessing somebody put the name, number, password as one of the things that feed into the algorithm. I just need to guess this other part, right? And with enough time and effort and probability, you might actually get there, right? So the idea is now that this particular key, the second key that was feed in, now it's on a rotation schedule. Maybe you never change your password, but at least the key is going to be sort of like every 2-3 months, and I think you can set it up to like every week if you really wanted to. It's gonna like say, oh, I'm gonna descramble everything and re-scramble it with a new key. And what that means is that even if I have a lot of time, it's going to be for naught, because by the time I figure out, oh, they used this key some time ago, it is nothing to do with the new key that I'm using right now.
You're starting from scratch, and and a lot of these take, with current computing power, they take hundreds, thousands of years to crack. So I mean, they're strong, but they're not. I mean, strong is not forever, and computing power is constantly changing. So you never know when that stuff is going to become completely obsolete. Yeah. Unless you're paying very close attention. So
no, and then there's the quantum computer is around the corner, and
oh well, yeah, and then we're all screwed anyways, right? So, but yeah, I mean, at the end of the day, key rotation is another tool that a lot of these cloud providers make very easy, where you don't really have to think too hard about it. You can just click. Yeah, it's a button click. So that's really nice.
Now the thing that is going to force you to do though is like it's not in a property on your file, it's not on an environment variable. Usually the way that we access these things is through some kind of library, right? So AWS will provide their AWS CLI libraries for Java, for Go, for all these other languages. And the thing is that you do have to do this quote unquote ceremony of connecting over there, saying, oh, it is really me. AWS will say like, oh, what is your identity and access management? And sort of like negotiate that. And then you have to sort of extract that and say like, oh, this is the particular thing I'm interested in, and trying to get that, which is 30 steps more than what you used to do. And I know, like, again, we keep saying like we know this is harder than what if you've never done it, we know this is way harder than what we usually do when we're starting out, but it's extremely necessary to create essentially commercial ready professional systems.
Right. But I mean, a lot of that ceremony is really encapsulated in the library. So you don't actually have to know it. What you do have to know is the same things we were talking about earlier, because most of the key, the secrets managers in these cloud solutions, they work on the roles again. So you're defining, hey, this is a role that I'm assigning to the VM or the function container that this app is running on that allows me to access the secrets manager. And I may even need to be specific on that role to say it can only access secrets that start with this prefix.
Right.
So when I'm designing keys for my secrets, it's really important to think about it almost just like you would think about a website taxonomy, like structured content, like a tree, where you can say, I only want to expose this part of my secrets manager to this application. Because if you just kind of wildcard everything, you're one step away from one application developer being able to read out and print all your secrets. Because the one thing a secrets manager will not protect you from is what happens when the secret gets delivered to the application. It is encrypted up until the point where your application receives it. It's receiving clear text in memory. So if I take a heap dump, for example, of a Java application that's running with a secret manager SDK, I'm going to catch the raw text value of that secret in the heap dump. Because within the memory, it needs to be passed to an auth header if it's an API key, or to the database JDBC driver in clear text if you're using a credential, a username password type credential. So there's still vulnerabilities even in the secrets manager. Nothing's perfect, right?
No, yeah.
But it corners you down to how well am I managing my roles and how well defined are my roles, and then how am I protecting my application? Because not just anyone should be able to run a heap dump on your application, right? But it makes you think, like, how many times have you been like, oh yeah, we have a vendor and they ask for a heap dump. Have you just sent a heap dump off to somebody and not really thought about what might be in it, right? When you're thinking about secrets in your application, you have to consider heap dumps. They have raw secrets in them.
Yeah.
Remember that.
No, it's crazy because it's a vector attack that you don't think about too much. Because most of the time, to be honest, like when you're looking at heap dumps, it's you yourself, right? Like you're the owner of the application, you're looking at it, you're trying to figure out something. But you're right in that you, like, if somebody else is asking for that particular heap dump, you have to be extra careful on, like, what are you sending over? Because the JVM will just, like, if you get the secret and put it on a string, and it happens to be a static string that you just keep forever, it's going to show up, right? Like if you happen to have, a secret that you retrieve at the moment, use for consuming something, and then you close the connection and essentially, remove like all the what is called like all the strong references to it. If there was not a full GC, it might still hang around. It's a little bit safer if you can, like sometimes you can afford it. You say, like, I only need to connect this once time, or I only need to retrieve the secret this once time, connect once, and then I'm done, right? Maybe some server that reads some other configurations that you just need to configure yourself, and then you're done with it. So that's the other part of this is, when you actually are handling variables that have the secret, try to reduce the time that these things need to be in flight as short as possible. Sometimes that's hard to do, or sometimes it's just impossible to do, but it's something that, like, if you know that you can avoid it, like, oh, I don't need to cache this. I can always retrieve it and just use it when I need it. A little bit better. It's not perfect. Nothing is perfect. The other part is, like, if somebody actually got access to your machine to do a heap dump, it's almost like game over anyways.
Yeah, no, it's serious. I mean, none of the approaches that we've talked about is going to protect you against that case. But I mean, that's why it's important to think about those things of who gets access to run heap dumps and have raw box access. I mean, that's why those types of access should be considered somewhat sacred within your organization. The other point that Freddie's alluding to is, hey, how can we keep our secrets short-lived, and what happens when I do that? So, part of the downside of the secrets managers is you have all that ceremony. So if you're only going to keep it in a request scope and you've got to request the secret on each and every request, that's a lot of overhead to get that secret. So there's usually needs to be some type of a balance between how you're storing the secret in memory and how you're letting it get garbage collected. It's really tough. I mean, in most situations, I will be honest, I am usually not managing the secret at a request scope because of those performance considerations.
Yeah. It's rare when you can actually do that.
Even I mean, because you still have that exposure during the in-flight request, where if you really have that level of system access, you're going to get it. Versus, if I'm putting things like in the other scenario where we're talking about, hey, we're just putting things in environment variable, I don't actually have to be in the Java process. All I need is a command prompt where I can just say, hey, print environment variables, and I may be able to start getting into at least the encrypted secrets values, or perhaps a raw secrets value, depending on how you're doing things. There's a number of those like container-based solutions where, hey, it's like, yeah, we have a secrets vault, but then once it connects to the container, it's like a text file and your secret's in clear text. So if I get access to the Docker container and a bash console, like it's game over for those secrets too, because there's no key being provided to encrypt the application. The application is running in a Docker container with text files that have the secrets in clear text, right? So, I mean, there's a number of I believe, like if you use, oh shoot, what's the name of it's one of the Kubernetes providers.
Helm or
no, I don't think it's Helm. Rancher used to do it that way, where if you had secrets that you had to buy in from the Rancher runtime, it would just be unsecured text files that get mounted to the Docker container at runtime. So you just have to know where your vulnerabilities are. And again, the secrets managers are to help minimize that, right? So if you can get your attack surface area down to somebody needs to take a heap dump, or they need to have role-based access where they have both access to the key as well as the secrets manager, you're in a pretty good spot, because you can limit the amount of people, you can limit the amount of VMs, you can create role-based policies that are narrow, so only certain applications can access certain secrets, and really cut down on what bad things can happen to you.
No, on the other layer that I've seen it done is like, for example, AWS will do, like the CLI will do this, where when you actually log into AWS through the command line interface, you put in your username, you put your password, and then the service will return what is called an authentication token. So, and for any request that you do to AWS, you don't need to pass in the username and password anymore. You just pass in the token. So what again, this is essentially what the industry is learning, that if you have a third-party API, sometimes they may say, okay, I need your username and password at the very beginning to know it is you, and then after that, I'm going to give you this little thing, which is an authentication token. I don't need your username and password anymore. You can just send me this token. The advantage that you have is that the token is usually very tied into that particular session, that particular source, that particular like resource that requested it. So if somebody just intercepts and tries to use your token, usually they're not going to be able to work. And the best part is that because you never really use the username and password for every request, for every access to the API, then even if they intercept the token, they know you didn't leak the actual username and password secrets that you were keeping. So that's sort of like the next layer where we know that having a username and password in memory is essentially vulnerable. So a lot of the services, what they're doing is like, I just need to receive it once, and then I'll give you something that will replace that, so you don't have to keep that around, and then you just keep sending me this token, and then I can work with that. And that is the reason why some of these services, again, if you ever wonder why do they always make me do this thing where I send them the stuff, they get me a token back, and I now need to use a token, is because they are trying to minimize, the transmission of these vulnerable things when, like when they're in transit.
Yeah, I mean that's exactly how like AWS STS works, right? So you basically have maybe a role on your account, or you have basically maybe a username and password that you use once to get the STS token, and then you can basically assume a role to do something, right? So you assume this role, and that role is a temporary credential. So I mean, the big thing what Freddie's talking about with it being a session is that your session is going to expire at some point. Usually it is a time-based thing. And in AWS, you can set it to be an hour. Like there's different levels of control. You can say how long these tokens are available. The OAuth protocol also has this sort of built in with access tokens, right? So you issue an access token, but it is for a specific amount of time, where after that time, yeah, you had a valid password and this token was valid, but it ain't anymore. Hey, we gave you a refresh token. If you want to use that to try to get a new one, you don't have to pass us a username and password. But if you don't have that, you got to log in again and get a new token. These things seem annoying, but they create smaller surface areas so that you don't have to store that username and password and keep passing the same thing. Because again, every time you send that over the network, yeah, it's encrypted with TLS and things like that. But what happens when people are recording that and they crack TLS? I mean, again, you want temporary credentials are great because they're not effective forever. So if somebody happens to crack that and gets that token, well, yeah, they got it 100 years too late. So it's worthless.
Yeah, no, definitely. And it's interesting because I love when the new websites will allow me to use like OAuth through like Google or Facebook, because I know that they will never get my real username and password. And like I will have control on the Google side to say like, look, I don't want this website to ever, essentially sort of like authorize through me or assume my identity for like logging in anymore. So it gives that like extra layer of security. Granted, this is not everywhere on the industry. This is usually the ones that are I guess the bigger players, or the APIs that have the most users or surface will start having these kind of things. Like I remember like JFrog does the same thing for the Artifactory product, where it will give you an authentication token that you can use with Gradle and Maven, and that is essentially what they're doing. But so that'll be the fourth part. Is like if you have access to use token-based authentication, use that.
Yeah, but I mean, as we've already been talking about, there is a little bit of ceremony that needs to be done on top of that. And again, that's one of those things that a lot of the cloud providers will hide from you in their libraries, that they're doing a lot of this. Hey, we're going to get you a new token after 30 minutes. And they're monitoring some of these timeouts that can happen in a long-lived, long-running app scenario. And really good providers that have been using these models for a while, they'll bake that into their APIs too, or they'll have some sort of a middleware or something that's constantly refreshing the token when it needs to be refreshed, so that you don't have to manage it. It is a huge pain in the ass when you have to do that stuff by hand. I've had to design things and do that sort of thing. It's maybe a step up from having to design your own crypto algorithms and things. It's very easy to get wrong. And it's very buggy, a very buggy process. So if you get a library and an SDK, use it. It makes your life so much simpler.
Also, pretty pleased now that we're talking about essentially retrieving secrets. But if you ever need to, like, for example, store secrets, let's say you're creating a username and password for a list of your users, there is a ton of literature on how to do that safely. If you're using a backing store like a MySQL or a SQL Server, they have very specific ways for you to like store those particular like encrypted columns. Do that. The one thing that you don't want is you don't want to store passwords in plain text, right? If you ever are in a position where, oh, I cannot put this on a secret store because a secret store, and that is actually an interesting clarifying point. A secret store is not meant to store, like, for example, your users or the users of your site's credentials, right? That is still falls into your responsibility. Secret stores are usually done for those, you as a consumer or your application as a consumer of an API, or a particular resource, that how can you keep those secrets safe? But it is never meant for your particular user, John Smo, going logging in to keep those secrets. That is, we need to do a different episode on that, on how to actually manage that safely. But yeah, at least the advice that we give you is, like, if you do need to store passwords, please never store them in plain text, because that's how we get this big leaks. And the problem is, like, you say, like, I'm a very small thing. What happens if they, like a greeting card site, and they stole my stuff? The problem is that a lot of these informations, people tend to reuse their passwords, even though we know it's not a good practice. But they will have an email and a plain text password. It's probably the same password they use for their bank account, and suddenly you become liable. And there is all these other things that you need to go through. So
there's actually a lot of different things you can go about that. And most of so to Freddie's point, the reason you don't usually use Secrets Manager is just the scale. I mean, most websites, when you're talking about users, you're talking about hundreds of thousands, millions of people. I mean, if you're talking about like a Facebook, potentially billions, right? So the idea of storing that in a secret store is maybe the wrong solution for that type of scale. So, but hey, maybe I'm thinking a database. Well, a lot of databases have encryption at rest solutions. And, I've actually worked with a few of them. I know for a client I once worked on setting up, I think it was a MySQL database with encryption and rest. And there's different ways to approach some of the problems that you have. So, I mean, like with Freddie, the problem you said, multiple users using the same exact password, right? There's different ways to encrypt those passwords. So there's deterministic keys and indeterministic keys that you can use to encrypt these passwords. So, if you use a deterministic key, it will, if I use password and somebody else uses password, they're encrypted and they're the same value. So if I'm going to go through a store and I can crack one of them and I know, hey, this guy's password, and then I find what his encrypted value looks like in the database, I can go down and find everybody else that has that password and hack a bunch of accounts. But there's also non-deterministic keys where we may have the same password, but the encrypted value is different because the way it's encrypting it is in a different format. Like they're using different keys, or it's done in a way that it's not predictable for me to be able to re-encrypt the same key and get the same value.
Right. I know, like there was a little bit of, like, they call it like salt and pepper that will actually, and that's, if you ever hear a hash with salt and pepper, that's what they're referring to, that there is like some kind of randomness to the way that is being encrypted to avoid exactly that, essentially hash collisions on passwords, because that is leaking more information that, oh, this other person has the same password as I do, right? So how about if we go a little bit into like one of the cloud providers and then show them how to create a key?
Sounds good.
Yeah. So let's see. I think you can see my screen, right?
Yep.
Let me make this a little bit bigger, since you might be watching this on YouTube. And this is AWS, right? The AWS console, on all the billions of services that they have, which coincidentally, US East one had an outage 3 days ago when Roomba, like, do you read about this? Roomba vacuum cleaners could not work.
I didn't hear about that.
They needed to actually they needed identity and access management. So they needed to go to IAM to authenticate. Boy. And apparently they couldn't. So it's like, nope, Roomba cannot vacuum today.
So AWS, if you're listening, we like you enough to use you as a demo, but we're still going to talk about your faults.
Yeah. It's tough love. To be fair, they're so notorious because they are right in between, right? Like most of the time, AWS has been rock solid for like all the stuff that we need to do, right? It said 2 days ago.
And that whole S3 thing a few years ago. But
Oh God, that
I
was
digress.
a finger, right?
Yeah.
Yeah, that wasn't even like that wasn't even like an outage. That was somebody like issuing the wrong command on the wrong terminal that did a rolling restart of the whole S3 infrastructure.
Yeah.
That's the stuff.
That's amazing.
Yeah, that is like, oh my gosh.
Blame the intern.
Yeah. Oh gosh. Yeah, I still need I need more HBO emails. All right. So AWS Secrets Manager is here. It's part of the AWS consoles, and it's very easy. The only thing you need to do is you should say store a secret. It has some credentials for like the stuff that AWS provides, but like most of the time you'll be using this, right? Like there's a third-party service, and this is my secret password, or like let's say API password, and then the value will be some super secret password, right? Which is a very bad, just so you know, this is a very bad password.
He's got 2 numbers in it. That should take much longer.
That throws him off, right? But yeah, so and then there is like there's the ability to use the encryption keys if you already have one, or you can use the default, and then after that, essentially you put in the secret name. And this is sort of like where Bob was saying, almost like the taxonomy of secrets, where you essentially can make it folder-like, where you say like, my app, client, and then, passwords, right? And then suddenly you can have a different taxonomy where you can say my app /server/password, or you can have, and suddenly, for example, if you want to create an application that needs access to both the client and the server, then AWS will say like, oh, anything that is beyond my app can be accessed by this particular role that you're assuming here, right? So that is when Bob is talking about taxonomy, it means this. It's like, how do you create the folder structure if there's many clients that may want to be using this particular secret?
Right. And a lot of companies like to partition by environments. So if you had my app prod or prod my app, you could make sure that your prod keys are never ending up in a development environment as well.
That is true. Like, interesting. Like where I work, it's where I work, we usually need to have separate. We actually even like separate by AWS account.
Mm-hmm.
That way, it's like really nobody can mess that up. You're in the test account or you're in the prod account. But if you happen, that is a very valid use case. If you happen to have one account that you're using both for test and prod, maybe that is what you want to do, where you do my app /test, or actually even better is just test my app client password, right? So some secret, right? Tags, this is a way for, if AWS allows you to create this tag, so you can group things by if you want to run reports about what's costing me this much money, then you can say this tag. Or if you want to do like, what application is this using, you can put it as a tag. And then this is the resource policy. We're not going to go into that. Click hit next. And then this is the secret rotation. This is actually the stuff that Bob was talking about, where, I can essentially say like, I want to re-encode my keys using a different key every, and it's really just that. It's like enable automatic rotation. You click down and say like, how many days, usually like, I really don't think I ever seen anyone really be more aggressive than 30 days, but maybe you have different needs. But
and then a Lambda function. Yeah. So there is a Lambda function that you do implement for doing the key rotation.
I see. And then this is the test Lambda function, which I'm going to put it on disable right now because I don't want to rotate, right? And then that is essentially it. Now, the fun part is that AWS, because it knows that if you're creating a secret, that you want to get that secret, right? So it gives you essentially the code already for getting the secret, right? And then public static void get secret is, is saying the secret name is test my app client password, the region, because these are usually split by region, US West 2, and essentially this is the AWS Secrets Manager client. And then essentially it's here like, oh, I need to make a request to get the secret with this particular name, which is the one that we have in the top, right? And then, this is the result, which is the actual secret that you got. And then once you get that, then you can actually do whatever you want with it, right? And I guess, yeah, get secret string, Oh,
This is if
okay.
you want to do the decoding in the app. So, I mean, at this point, when you get the secret value, it's still encrypted until you apply
The
until you apply the decode method. So well,
oh,
that's
no,
just a
yeah,
base
yeah.
64 actually.
No. So this is if you have, so this is crazy. There are some APIs out there that live to do binary secrets, which is like not your regular, like, like UTF-8 strings. And I guess that this is, if you happen, like, we did not create one of those. We created just a regular string. So this is enough for most people. But I have run into very old systems that their password, quote unquote, is essentially a byte buffer of things. And for those, then essentially it's a base 64,
secret binary. Yep, I got it.
Yeah. So the interesting is that it gives you the code. The only thing you need to do is, and I thought I found it over here. So this is essentially, you will need to add this particular maybe or greater dependency.
Well, if you're using Spring, you will.
Oh no, yeah, this is for Spring Cloud.
Yeah, because there's an independent AWS Secrets Manager library. Yeah, which will just give you the Java SDK.
Right, right.
And you can send those requests.
Yeah. So
yeah, if you're using Spring, it does absolutely make sense to use the
Spring Cloud. And I'm gonna go over that for a little bit, just in a couple of seconds. But first, let me wrap that up, the non-Spring one, which is, you have to add this Gradle dependency. This will give you access to this particular AWS Secrets Manager, and allows you to do all this, right? And then let me just click on store.
And this is already assuming that where you're running it has access. So you've already got an AWS credential that can call the Secrets Manager. So this is assume it's running in a VM that has this role, or you have an AWS key and secret that's been authenticated that can call the Secrets Manager.
Correct. So for those who don't, the way that, yeah, like for those who are unfamiliar with this, the way that AWS CLI works is like, and I wonder if I actually have it here. Let me just see if I can. At the very, I don't know if I can log in. Yeah, let's see. Just log it, right? So no.
Yeah, Secrets Manager's there, but
yeah.
Are you logged in, and do you want to share your company's login information with the rest of the world?
Yeah, no, let's not do that. But but the idea is that the AWS is a command line tool that you can install in your particular Linux distribution or Windows, and it will it will authenticate against your actual AWS essentially console, right? So the idea is that you can then, and the way that it authenticates is quote unquote the nice way, which is you authenticate once and AWS will send you back a token. And then that token is essentially your session. It usually lasts for 1 hour, 2 hours. I think you can set the timeout, which is never a good idea to send it more than like 6 hours. just because you don't want to
A
have
lot
that
can
running.
happen in 6 hours.
Yes, right. So we usually do it for 1 or 2 hours. I mean, it really takes like 10 keystrokes to re-log in when you need to generate a new token. But once you have that, then this code here is smart enough to either do two things, or the code that we were looking at. Where is it? Actions. No, I don't want to delete the secret. Retrieve secret value. You can actually, on the AWS, you can actually look at the values on there. But the one thing is that this Secrets Manager builder, what it's going to do is it's kind of clever, where it will first look at, oh, is there any token around the computer that I'm running, right? And when you actually use the AWS CLI login, it will create a token that is stored in your home folder. So the Secret Manager client builder, as part of Authenticate, is like, oh, is there a token in there? And if it finds a token, then it's like, I'm just going to use this token for me to get the secret, right? If this code happens to be running on an EC2 or AWS provision instance, what it's going to then do is like, oh, I recognize that I'm running on a provision instance. That means that this particular EC2 ECS has a role that I can assume to get credentials, right? And then so it will use that automatically without you having to do this song and dance. It's like, oh, if I'm running in dev, I should use my token. If I'm running on AWS, I should use my AWS role. Like, all of that is taken care of. They try to make it, because, and I think that, because we know that this is painful compared to storing just a string on your configuration file. A lot of these services try to make it as simple as possible to be able to be used, right?
The default credential provider in AWS is a very, very, it's like a hierarchical thing. I mean, so it'll start, there's actually a precedent documented that they have. I mean, so it'll look at everything from your home directory to the role structure, to making a well-known URI call within the VM to obtain this token, to looking at environment variables, to looking at properties files in different locations. So there's actually, like, I want to say there's almost like 5 or 6 precedents where it will go through all these things. And if it doesn't find your credential, then it won't work. It's on you.
I
tried. And there's ways to override that if you don't want it to look in certain spots, because you may actually want to not use the default provider if you're trying to only make sure it looks in certain things. Because when you're running on your laptop, you may have credentials all over the place, depending on how organized of a developer you are. But you can lock it down as well. But the default provider is very strong. But looking at the console here, where you can still see the secret in the console, just makes it, you can't emphasize enough how important it is to actually lock down your cloud account, because that then becomes the skeleton key to your entire infrastructure. You better trust your employees that have admin access to these
whoever
things.
have access to Secrets Manager, it must be in the circle of trust, right?
Yes.
Yeah. Right. Now, I think at least I wanted to cover very quickly on how Spring does it. Spring Cloud specifically. Is there anything else that I'm missing on this, or I think it's
no? I think you got it covered. I mean, you talked a little about rotation. We talked about creating keys. We talked about taxonomy, and then in my mind, those are kind of the big 3.
Got it. All right. So if you happen to be using a somewhat recent version of Spring, Spring is essentially came out with something called Spring Cloud, which is the answer that they have for a lot of these providers that are coming online, right? Like Spring decided, look, everybody's making the cloud play. There is providers for AWS, there's Oracle providers, everybody's have their own cloud, right? So one of the things that Spring Cloud did is essentially, all of these cloud providers are doing exactly the same thing. They're trying to get to a key store. They have ways to have a storage. They have ways to connect to data sources, all these things. So what Spring Cloud did is like, let's just consolidate it a little bit like SLF4J. I don't know if you haven't heard our logging episode some years ago. It is the same idea where there's this Oracle cloud provider, AWS cloud provider, Microsoft cloud provider, which is turning out to be big on Java now, that do the same thing. And will there be a way for us to, quote unquote, do this thing seamlessly across the three of them, right? And the Spring Cloud is essentially the answer to that. One of the things that Spring Cloud did is that when you include Spring Cloud AWS in your project, it comes with a integration with the Secret Manager. And the way that works is kind of fun because it almost makes your application work as if you just entered the password as part of your YAML file. So if you think about, let's see, we have it let's say for example that I have some kind of application properties, right? And then I do username equals some username, right? So let's say API username, right? We already said that the thing that you should not do is you shouldn't do this, right? API password equals oops, right? You're not supposed to do this. But it's very easy to work this way, right? Because like maybe you even want to do this when you're working locally because you're like, oh, I need just to do the API password. The thing is that Spring Cloud simulates this particular behavior and says like, I'm going to take everything that is in your Secrets Manager that is in a particular taxonomy and add it as if it was in your application properties. So as long as you follow, once you add in Spring Cloud as part of your application, as long
specifically the secrets starter. So it's not just Spring Cloud. You actually need to add the secrets starter dependency, right?
I think it's AWS Spring Cloud will come with it by default. And I think you can maybe pick and choose if you don't get the big cloud package. But if you do the Spring Cloud AWS, it will come with the secret integration. So then what happens is like, if I want to integrate, as long as I do it like /secret/ my service name, right? Or I do /secret. If I do /application, this is a secret that is shared across any Spring Cloud application that I happen to be running. So that's very, very big, right? If I do secret/ application production, that will be essentially any application that had the profile of production. For those who work on AWS, you know that Spring has the concept of different profiles. And the profiles is like if you're running on dev, if you're running on prod, if you're running on integration test, that's how it sort of separates the different configurations. So in that sense, if you happen to do _production_test, that's how you sort of split the different secrets by Spring profile that is being used. I tend to gravitate to this one, which is the name of my service _production/_test. And when you do it that way, like let's say, for example, I go back to my Secrets Manager and I decided that then, oh, I'm gonna edit the description. Oh, not the description. I need to.
You want to add a new secret value.
Yeah, I think it's better just to, I decided to create another one, and then I said like /secret, and let's say the IAM role that I use is called pub house, and then I think that's.
I don't think so. No. The secret name is at the top.
Oh, sorry.
So
I
missed the one thing to mention about Secrets Manager that's different from SSM. SSM, you only get one name value type pair. But in Secrets Manager, you can do multiple rows.
Right.
And that's the reason this works, so that you can set a profile and have, hey, this is available to every application. Well, you're defining multiple secrets in here. You don't have to worry about one key, one value. But if you do it with SSM, it's a little different.
See, yeah, because you were right. What I was doing, I was creating the entries for the secret, and I can have multiple of those.
Right.
But this is where you put in the taxonomy. And if I put a taxonomy as /secret/pub house,
that would be the service-like one, right?
Yep. Yeah. So pub house will be essentially the IAM role that I am impersonating on that particular deployment, right? And I can do pub house _ prod if I want to do the production keys, or pub house _ test, right? And when I do it this way,
I don't think it's IAM. Pub house is the name of the service.
Yes, you're right. Because
so, when you start Spring up, often you assign a name to your service.
Yep, you're right.
That's what you're gonna call it, and that's what's gonna pull it in. So, I mean, again, at the same time, Spring is very opinionated. When we talk to our buddy Michael Manella, he's willing to tell us and explain why they have all these opinions. But the one thing to keep in mind is, if you use Spring Cloud, it is going to have this opinion on how you structure your secrets manager. It is going to tell you, use our taxonomy.
/secret. This is how it is, right?
Which, gives you one less thing to think about. But if you have other things in there, it may give you a lot more to think about.
No, right. This works great. Like if your ecosystem is in such a way that you say, like, I can rely on Spring for these things, then it does make a lot of pain go away. Because like the fun part about doing it this way is that when I start up my application, it is like, if I have this line in here and I really don't have to think about anything. But if there is some weird thing where the way that Spring does things is not the way that you want to do things, then yeah, all bets are off. Like it could be, they do try to configure things. Like they give you like, ooh, if you want a different prefix, if you want a different context, if you want a profile separator, right? Like they try to do these things, but it is doing heavy lifting on the back, on the like you're relinquishing control on some of these opinions, so that you just don't have to worry about it, and things will look like if it was your regular Spring property value in there. And that's great. If you can sort of like piggyback on that, go for it. If you are on a level where, no, that's not going to work for me because we do multiple things and there are other people that need this and we cannot change the taxonomy the way it is, then yeah, don't use it. Or if you happen to start a new project that has no preconceptions, then
no problem. Just use theirs. Yeah.
No, I mean, it's like,
yeah. No, I mean, that's the beauty of it.
Yeah, then go with it. All right. I think that is the most I wanted to go on and stuff. And I know we cover AWS, and that is just because that is the easiest one to cover. Let me delete my secrets because they charge you 40 cents a month per secret.
We're very cheap. Buy us a beer. We'll keep secrets longer.
Right. But no, that is another thing. Just so you know that none of these, or unless you stand your own HashiCorp vault, all of these cloud providers, they will charge you for this, right? And so no waiting period 0 days, because you're going to charge me up. Wow, I need to wait 7 days. I guess so. So I'll pay the 7
Buy
cents.
Freddie a beer and he'll start feeling better about all this.
I know. Yeah. So another reason why you don't want to have millions of users credentials in your secrets manager. They'll charge you for each one of them. But yeah, like that is something of a little caveat. Just remember that they are a great infrastructure, but it is a service that like AWS is good at. AWS will charge you 40 cents per secret per month. and 5 cents per 10,000 API calls. So you cannot also go gung-ho and call it, I guess, for every request either if you have high traffic, right? So so that's it.
Yeah, no, I mean, that was a pretty comprehensive cover. I mean, we got into a number of things that I don't even think we planned to get into, but hey,
it's exciting. Like no, well, it's exciting because this is if you manage to catch this particular episode and really listen to it, it's one of those that we can help you avoid career-ending mistakes. Like, right? Like you know, nary a person has been fired for putting tokens and passwords in GitHub, and I was just looking for test123 as a password. And yes, there is like projects that will have that as a plain text. So that's why, like, do not do that. Do not put your credentials on source control, because somebody can just really just search for them. So so that's it. And I know like it's something that you don't want to think about, but good security is just it's just a step to get to that level of professionalism where, you know, like you know, never be afraid to push back on these things. It's like somebody is like, no, this is too complicated, we have to pay for it. It's like, you don't understand. I'm trying to save the company, you know, headaches.
Being in the news these days.
And it is. And I know they say like any news is good news. I don't know if that's exactly right for this, right? So so please, you know, you know, listen to this again, pay attention to it. This is one of those like tenets where you can know that like, oh gosh, you're investing in your career. This will be one of the things. It's like having respect for how to store secrets is a big part of being a professional developer.
Yep. And it doesn't matter which provider you use, as long as you use something and you don't try to invent it yourself. Don't do what I did.
Yes, that is right. You know, like it's not an intern project that, oh, I'm gonna create a secret store. No, you know, if you really need to stand up your own, at the very least, use, you know, like the community edition of HashiCorp within your network, right? Like that. At least the guys are saying, look, we made the hard parts already. You just have to, you know, secure and run this securely, which is still a challenge, but way better than, oh, I'm just gonna store everything on a Microsoft Access database. So, which I'm dating myself, but I actually had projects that did that. So, all right, and I think with that, those are that is the end of this episode 99. I wonder what we should talk for episode 100. It's going to be a big one.
Yeah, we'll have to come up with something big for triple digits
for the centennial
really
episode. Yeah, you know, do remember that we have other podcasts that, you know, Bob and I or some of our cohorts are part of. You know, we have Java Auth, which is our newscast, and we also have Stacked, which is our sort of like more web-centric, sort of like web technology-centric podcast that, you know, Josh, the man, and Daniel, the host, and Leon runs. So give them all a shot. So that's it. You know, the holidays are coming, so there might be a lot of free time. That's it. Happy programming, everyone.
All right. Bye, everybody.